But before jumping into this session, please let me welcome on stage Mr. Samadin Asadov, Chairman of the Board of Azakosmos, the Space Agency of the Republic of Azerbaijan, the host of the IC 2023, for some opening remarks. Samadin, please.
Dear ladies and gentlemen, dear guests, it is my biggest pleasure to welcome you at this plenary event. I hope you have enjoyed the opening ceremony. I'm sure you will. Thank you very much. We did our best, to be honest. I'm sure we will have a very productive week ahead. As a space agency of the Azerbaijan Republic, we give a big importance to the international cooperation, and we are very much open to any kind of collaboration. I'm honored to welcome our speakers at this panel. I look forward to listening to them who are at the foremost of the space industry. Thank you, and wishing you a pleasant day ahead. Thank you.
Thank you, Mr. Asadov, and once again, congratulations to this outstanding opening ceremony. And now let us jump into our first one-to-one interview, and I hand over to our president, Clay Murray.
Thank you. I'm going to invite Pam Melroy up on stage. Pam, if you don't know her, is pretty impressive. She's the deputy administrator at NASA, but she started her career commissioned officer in the United States Air Force, where she was a pilot and commander. She flew over 200 hours of combat and combat support missions. She's rated on 50 aircraft, no small feat. She commanded 2 shuttle missions. I think one of only 2 women to command a space shuttle. Has over 38 days in space. She worked in industry for DARPA. She worked as an advisor to the Australian government, the Australian Space Agency. She's been a tremendous supporter of international cooperation in space. We're really pleased to have you. And now, obviously, she's serving as deputy administrator, and we welcome you here and thank you for coming today.
Well, thank you for inviting me, Clay. It's wonderful to be here and to see old friends and new ones.
So let's start off. You know, in space, we love acronyms, right? We absolutely, we can't do without acronyms in space. And so I want to start with a question about Lunar Surface Innovation Consortium, LSIC. I read that and I said, what is that one? I had to look it up, right? Which sorry, but I can't remember all of the acronyms out there. So,
fair enough. It gets really hard when we use them for 2 different things too.
So NASA's been very deliberate in communicating as they look at exploration to include both industry and international cooperation as you move forward, particularly as we look at going back to the moon and onto Mars. Can you talk about the consortium? How does that work? And how's it going to work in practice for NASA?
Yeah, Clay, we are so proud of the Lunar Surface Innovation Consortium, or LSIC, as we call it for short. And we were absolutely astounded at the response. So the interesting thing about a consortium is that there's no one set rule for how you set it up, or even a single funding model. In this case, we decided to fund the LSIC to create a community, because not only do we want to talk to our industry partners as we go forward to the moon and our academic partners, we wanted them talking to each other. And so it's really important, if you're trying to build a community, a consortium is a perfect mechanism for that. We have over 3,000 participants from 900 different organizations across 57 countries. And they are a very robust organization. They meet biannually, everyone together. In addition to that, there's monthly and weekly meetings for some of the working groups, and there's specific working groups around topics that we're most concerned about, with things like dust mitigation, which is very hard on the moon. It's really been a phenomenal response.
Fantastic. All right, so I got another one, COSMIC, okay?
Yeah, that's a snappier acronym.
It's a little bit snappier than LSIC, but we'll work on the LSIC one. NASA announced a new consortium there, talk about in-space servicing, assembly, and manufacturing capabilities were really all core if we're going to learn how to live and actually work in outer space. Why is this an important step? Why does ISEM matter so much?
Well, I think one of the things that's interesting about on-orbit servicing, assembly, and manufacturing is that we recognize there's now a growing commercial interest in this, but there's always been such a strong academic community around robotics and some of the other technologies, advanced manufacturing, and so forth. So we looked at LSIC and said, we want to try to do the same thing. We want to create a community that's talking together and focusing on the most important problems. So COSMIC is our effort to do that. To be expedient, we're starting out with U.S. entities only, but we are partnering, and I hope I get special credit for naming a third consortium all in like the first 2 minutes. The consortium for the execution of rendezvous and servicing confers, which is an international industry-led consortium for standards and best practices to be communicated specifically around on-orbit servicing. So right now, confers is the best way to engage with us on COSMIC, but as we look to expand, there will be more.
Okay. All right, we all want to go back to the moon, right? This is the objective, and during the opening ceremony, we celebrated the Artemis 1 successful mission, Artemis 2, okay? So Artemis 2, you guys have announced now a team of astronauts to go back to the moon. Can you talk a little bit about that? It's super exciting. I know ESA and the Canadians are involved as well. So
absolutely, we all of our missions engage. Of course, ESA is providing the service module for Orion. In the case of the Artemis 2 crew, we will also have our first international crew go beyond low Earth orbit together. So that's Canadian Jeremy Hansen will join the crew, led by Commander Reed Wiseman and his pilot Victor Glover and mission specialist Christina Cook. And she will also be the first woman to go beyond low Earth orbit. So very exciting, and the crew is busy. They're going through training. First of all, they went out to see how the recovery operations would look like. So they went out to San Diego, the west coast of the United States, to practice what it was going to be like when they were recovered from the ocean after Orion splashes down. And then just about 10 days ago, they did the other end of the rehearsal, the ops rehearsal, which was to go out to the Kennedy Space Center and do day of launch walk down, all the activities, even practicing walk out and going out to the pad. But we have a lot of hardware in work, not just for Artemis 2, but also for 3 and 4. So we're assembling pieces, we're preparing and upgrading the mobile launch platform. There's a lot going on.
I was in Bremen just a couple of weeks ago, and it was actually the same time that the astronauts were there. I didn't get to meet them. I was kind of disappointed, but they did take me into the clean room where they're building the service module. It was super exciting to see the hardware.
The administrator and I have been there as well, and just really appreciate our ESA partners. I think it's always really important for us to send our astronauts out so that the people who are touching the hardware actually get to see the face of the human who's going to fly it.
I know Airbus is very proud to be building it. So, all right, science. Let's talk about science and a little bit about climate change, right? It's no secret that we're experiencing extreme weather around the world. The climate change is upon us. We could see just this past week in New York City, extreme flooding that was taking place. And we're using space. I was talking earlier with the UN workshop on Saturday about how they have 54 data sets that they look at on climate change. And 26 of them come from outer space exclusively. So really, like about half almost of the data that we're looking at comes from there. So can you talk a little bit about how NASA views this, how we use satellites in space to understand what's happening on our planet?
Absolutely. NASA is a space agency, of course. We're also an aeronautics agency. Not everyone knows that, but we are also a climate agency. Climate is quite interesting. As you point out, it's actually much more efficient to instrument the Earth and look at it from space because you can get scales that you simply cannot do on a terrestrial basis to get certain types of measurements. Not that those data sets aren't important. They validate the data from space, anchor it, and calibrate it. So that's incredibly important. But NASA is very proud of the fact that we have expertise in looking at planets and turning that expertise back on the Earth so that we can understand what's happening to the Earth is critically important. But it's really only the first step, because climate isn't weather. All of you know what to do with a weather forecast. You know exactly what it means. You're going to bring an umbrella or you won't, or what you're going to wear. Maybe if there's a hurricane coming, you will know what to do. But climate forecasts are not easy to understand. So we play a role in developing models that help us predict what's going to happen. But then we do outreach at every single level, from the tribal, local communities, state, government, and international level, to help users understand what that data means. It's really important. We recently opened an Earth Information Center, which is also available virtually to be able to visualize some of the things in our changing climate.
That's the EIC, if you weren't paying attention.
EIC, Earth Information
Center. Excuse me. Yeah, center. Okay. International collaboration and partnerships. We're here at the IC. This morning you were talking a little bit about that with the James Webb Space Telescope. NASA really, about a decade ago, really kind of a paradigm shift in doing commercial resupply services and commercial crew for the space station. This was really kind of a real change in the way that NASA went around about buying and purchasing, working with industry, purchasing services to go to space and human spaceflight services, which is really sort of an interesting thing, right? So how do you see that now going forward? We have LEO, we're going back to the moon. How do you see commercial playing a role in that and international cooperation?
It's actually central to our strategy and has been for a while that partnership is critical. One of the things I like to say is that every country has a border with space. So international collaboration and cooperation is essential. But we also saw that our industry was prepared to take on some of the responsibilities without the same level of oversight, and in fact, have it be a true partnership. And especially where commercial companies see the opportunity to build other customers, whether it be other international partners or other commercial partners, then that kind of co-investment works really well with commercial cargo and crew, because then NASA got a capability at lower cost. In addition to that, we began to really build our industry capacity. And I think it's an interesting playbook for others to look at.
Okay, very good. Christian, I don't know if you want to invite the audience to ask questions through our app here. I have an iPad here. I can actually view your questions if you want to start.
As usually, please use our app to ask questions. Our audience, our speakers will be happy to answer them. You see here on the screen how to join the Slido platform. So do please ask questions.
Okay, while I'm waiting for the questions, can you tell us a little bit about SLS? Where is SLS heading these days?
Yes, okay, we've got a lot going on right now. Boosters getting ready to go for Artemis 2 out to the pad, working on integration of the rocket engines to the core stage. So there's a lot happening. But in addition to that, we are taking the steps to figure out how to have greater efficiencies by working better with our commercial partners. And we're gradually moving in the direction of a commercial capability that could be offered to other customers eventually for SLS, although we expect that we will be filling up the manifest for the first 7 or 8 years for sure.
Very good. And I know I missed it, but I know DLR just signed, I guess the Germans just signed on to the Artemis Accords in Washington, is that?
Yes, that was a delightful moment for us. Great joy with the head of DLR, Walter Peltzer, who's a dear friend. We were really just ecstatic with joy when they joined. Strong voice and, of course, leadership of the council right now. And we look forward to welcoming them to our Artemis Accords signatory event.
How many signatories do you have now for the Artemis?
We're up to 29.
29. And
yes.
Is that the largest set of international partners for any accord, or are you?
Oh, I don't know.
Don't know.
I think from our perspective, we really want to try to take the next steps. So tomorrow we're going to meet the signatories, Will, as we did a year ago in IAC, and start to do some work around the accords, take the next step. What does it really mean? So stay tuned. We'll have a press conference afterwards to tell the story.
Okay, very good. All right, well, I'm going to let you go. Thank you so much for the update. I really appreciate it.
Thanks a lot, Pam Melroy. And it is now time to switch to the other side of the stage here. And I give the word to Michal Hashemimri for our next interview.
Thank you, Christian. Good afternoon, Dr. Li Guoping. We are very happy to have you here. And we've seen a lot of good news about China and their achievement in space. And so what we wanted to know is, could you share with us which of these achievements are the most important? And what is the focus of the Chinese National Space Administration in the upcoming years?
好，谢谢主持人。Thank you very much. 首先，我想代表中国国家航天局对这次大会的这个召开表示热烈的祝贺，还要对国际宇航联合会、阿塞拜疆航天局等有关单位为筹备本次会议所做出的辛勤努力致以诚挚的感谢。First of all, on behalf of China National Space Administration, I would like to extend my sincere gratitude for organizing this wonderful meeting in Baku. The efforts made by all the teams of IAF and the related teams, thank you very much. 从去年9月份到今年9月份，在过去1年时间里面，中国已经实施了65次发射，将200多个航天器送入轨道。So in past year, from September last year to this year, we have conducted 65 launches, sending over 200 spacecrafts into orbit. 应该说这个航天器啊各具特色。我感觉印象最深的应该是第一个是中国空间站已经正式建设运行。There are different types of spacecrafts, but the most impressive to me also is the completion of the China space station, and that is already put into normal operation right now. 中国的夸父1号太阳观测卫星成功发射。And the successful launch of Kwafu-1, which is the solar observation satellite, has been successfully launched. 中国的科学家在对中国嫦娥5号采回了这个月球样品进行科学研究，发现了新的月球矿物质，我们取名字叫嫦娥石。The Chinese scientists have done research on the samples we get from Chang'e 5 mission from the moon and discovered new material we called Chang'e stone. 中国呢，利用中国的天问1号火星探测器获取的这个火星数据，制作了这个高分辨率的全球火星影像图。And China's Tianwen-1 mission has completely successfully already getting the full image, the high resolution full image of the Mars. 关于后续的一些发展呢，我们后面有一个 PPT， 一篇 PPT， 我做个简要的介绍。For the past successes that has been shown on the presentation. 首先是关于月球探测方面，我们即将在2024年发射嫦娥6号探测器。这次任务呢是主要是到月球的背面进行取样返回。First of all is for the Chang'e 6 that is planned to be launched in 2024. That is going to getting samples from the far side of the moon. 为了完成好这次任务呢，我们还要在这之前要发射一颗中继卫星，叫鹊桥2号。So for supporting this mission, we are going to launch our 鹊桥 second satellite, that is a data relay satellite for the whole mission. 来自法国、意大利、伊萨的载荷，还有巴基斯坦研制的立方星，将随同这次任务一起奔向月球。There are also some international payloads from France, Italy, and ESA, and a CubeSat from Pakistan will be piggybacked on the mission. 我们将在2026年实施嫦娥7号任务。这次任务呢，主要是到月球的南极进行着陆，开展巡视探测和飞跃探测。On 2026, we are planning to launch the Chang'e 7. This mission is going to target the south pole of the moon and perform the landing, patrol, and flying by detection. 目前有8个国家提出了载荷的搭载建议，有可能加入这次嫦娥7号任务。Currently, you have received over proposals for piggyback international proposals for piggybacking payload from over 8 countries.
我们将在2028年跟它实施这个嫦娥8号任务。这次任务呢，也是要到月球的南极着陆，开展巡视探测，同时还有一个机器人探测。
In 2028, we are planning to launch a Chang'e 8. So this mission, we're going to land on the south pole of the moon as well, and getting the detection from patrolling and also the robotic detection.
当然，这次任务目前还正在这个前期设计论证之中。
Currently, this mission is on the planned feasibility studies.
目前我们还在开展那个月球科研站的这个前期论证工作。这是我们这个嫦娥8号任务啊，也是为月球科研站的最终的建设做好是一个先导专项。
At the same time, we are also planning to establish an international lunar research station on the moon surface and orbit, and the Chang'e 8 actually is a navigating program for this mission.
另外呢，中国目前已经启动了这个中国的载人登月计划，目标是在2030年前把中国的宇航员送这个月球表面。
And China also initiated the manned lunar program, the targeting to deliver the astronauts to the moon by 2030.
在行星探测方面，我们计划在2025年实施天问2号任务。这次任务呢，主要是在对小行星进行取样返回，并对主太彗星进行探测。
There's also for the interplanetary exploration programs, we're planning to launch the Tianwen-2 satellite to getting samples from the asteroids.
我们的天问3号任务是主要目标任务呢，是要实现火星的取样返回。目前我们的目标是在2028年实施这次任务。
The Tianwen-3 mission is we'll plan to getting samples and a return to Earth from the Mars, and the time schedule is around 2028.
天问4号任务呢，主要是实现对木星或木卫的卫星进行探测，并实现行星际穿越，计划在2030年实施。
The Tianwen-8 program, the target of this mission is to conduct exploration of the Jupiter and the Callisto, and also conduct the interplanetary flying by detection.
目前我们嫦娥8号任务是开放的，我们计划提供至少不少于200公斤的大载机会。
The Chang'e 8 mission is also open to international cooperation. We will provide at least over 200 kilograms of payload capacity to international payloads.
我们也欢迎有志的国家同中国一起来开展月球科研站的建设。
We welcome countries to participate in this mission and also the mission of IOIS.
另外呢，我们中国的嫦娥5号采样的返回这个月壤也向国际同行们开放，大家可以申请来开展科学研究。那么这个相关的资料可以查阅中国的国家航天局的网站。
And also the samples we get from the moon from the Chang'e 5 mission is also open to international community to do the scientific research. And if you need any further information, please check our website.
另外呢，我们在对地观测卫星、通信广播卫星、空间科学卫星方面，也还有新的研究科学计划，包括我们还要开展这个新一代载人运载火箭或重型运载火箭的研制。有时间的关系，我就不一一详细介绍了。
And also for the other aspects, including remote sensing satellites, scientific satellites, and communication satellites, we have also various plans, including another plan like the manned heavy lift launch vehicle development. So according to because of the restrictions of the time, so we will give any more details at this occasion. 谢谢。
Thank you. I was
Thank
going to
you.
ask you about the climate and environment, but then I guess we can skip to something that everybody is really interested about, which is the International Lunar Research Station. As a huge international cooperation program for lunar exploration, how do you see CNSA plan to cooperate with international partners on this program?
的确，月球科研站呢，就是中国的科学家们在几年前就在酝酿启动这个月球科研站的计划。
The ICE program is actually initiated a few years ago by Chinese scientists.
我们刚才说了，我们这个已经开展那个嫦娥6号、7号、8号这些任务啊，都可以为后续的月球科研站的这个建设呀打下一个很好的基础。
As I mentioned, the Chang'e 6, Chang'e 7, and also Chang'e 8 will be the laying the foundations for the future ILS construction.
因为这个月球开展呢是个长期的任务，我们的目标呢就是要在月球的轨道上和月球的表面建立一些长期能够稳定运行的一些设备设施。这个
The target of this mission is to establish a long-term stable operation of payloads and the spacecrafts on the orbit and also the surface of the moon.
将来呢，如果我们宇航员这个登陆月球以后，也可以在短期内在我们的月球开展呢开展一些科学研究。
And in the future, when astronauts go to the moon, they also can be conducting some scientific research using the ILS facilities.
因为这个项计划是开放的，我们正在同多个国际合作伙伴在开展这个双边的或多边的交流。
This program totally open. We are actually currently negotiating and discussion with various countries and international organizations in a bilateral and a multilateral way.
这个合作的方式可以是多样的，比如说可以有些国家可以承担一个单独的一个，比如说这个航天器设备设施等或中国的设备设施一起形成这个一个联合的一个科研站，这相当于在系统这个层面开展合作。
So the cooperation model can be very actually various. We open to different levels of collaboration. Some countries or partners can conduct their own missions, combining together with ILS, and we all can also collaborate in the system level as well.
当然了，各个国家呢可以根据自己的这个实际情况，你可以负责部分的这个有效载荷、部分的分系统这个层面的这个产品，这也是一种合作方式。
And of course, we accept different levels of collaboration. So different partners can, depending on their own situations and technical capabilities, because providing some payloads or instruments, they're all welcome.
当然，还有更多的我们科学家一起利用这些设备设施所获取的信息，来共同开展一些必要的科学研究。
And another level of collaboration is also on the scientific research level by analyzing the data and the samples returned from the IS mission.
因为这个建设这个最终建成这个月球科研站是一个长期的我预计肯定要到35年到40年之前才能正式最终建成。
So the construction of the whole mission will be a very long term, and we expect to finish the program completion of the IS station around 2035 to 2040.
有关这个方面的详细情况呢，待会儿我们在4点半也在这个大堂里面还有一个专题的报告，也欢迎大家来了解一些相关的情况。
And for more details, there will be a GNF specifically on the IOS topic. Also today, this afternoon, at this auditorium, we welcome all the participants to come and learn more details.
Thank you so much for your time. Thank you for your input. Appreciate it.
Thanks a lot, Mr. Li Guoping. And it's my pleasure now to switch back on that side of the stage, give the word again back to our President, Kay Maury.
Thank you, Christian. So I'm pleased to welcome Her Excellency Sarah Al-Amiri, the chair of the UAE Space Agency, to join us. Incredible career rise for you, really, starting at a very young age, managing as Deputy Program Manager for the HOPE project to send a satellite around Mars. This is an amazing accomplishment, and at a young age now, she's chairing the UAE Space Agency. I'm really pleased to have you, and thank you for coming.
Pleasure, thank you.
So the UAE is accelerating very rapidly. I think almost a model for a lot of the other space agencies that are trying to develop and emerge and achieve. What do you give in terms of the background, or why is it that the UAE is so really moving fast in space? What's the secret? Is there anything you can share with the other space agencies?
So very good afternoon to everyone here. And first off, I'd love to thank the organizers on an amazing setup over the course of the last few hours of this event. In terms of the UAE's space sector, and the key driver, if we go back in time on establishing the space sector in the first place, was a transition into establishing more sectors that are based on knowledge and more sectors that utilize technology and utilize science as drivers for those developments. And how that was then translated into action is first off development of capabilities in design and development of complex technological systems. Spacecrafts bring that about. And then enhancing that further with scientific discovery to bring together all the different elements of research development to commercialization in terms of its advancement and development. So the UAE purposely chose areas within the space sector to invest in. First off, from a commercial perspective, we have one of the top 10 satellite service providers, Yasat, based out of the UAE in terms of space communications. And that's a venue that we will continue investing in as a country and enhancing the development there. We also started a very small Earth observation satellite development program, but how this is translating today is in utilization of data from different data sets and different space assets around the world. So there's a large drive of supporting private businesses and startups in establishing Earth observation services for various sectors support. Our exploration mission continues, be it our mission that's around Mars today that's still providing the science community with unique scientific data. We are continuing on building our next, even more challenging mission to the asteroid belt that is due for launch in 2028. On top of the challenge of developing that mission, we took a purposeful approach as a government to ensure that we take whatever knowledge has been acquired in the public sphere and start transferring it onto the private sector. So our mission to the asteroid belt, although it's a scientific mission driven by research and development, built on past knowledge of design and development that we've experienced in the Mars mission, we've already contracted 3 different companies, most of them startups, to start developing portions of that spacecraft or the services that are associated with that. That's a conscious decision to continue establishing the space sector as an industrial sector within our economy. And a lot of our space fund, that's roughly 3 billion dirhams, close to about $800 million, is going towards supporting private businesses and individuals in establishing their space sector presence. So research and development is continuing, human exploration is continuing, underlying international collaboration is also continuing, but underlying all of this today is the real benefit of economic driver that's currently being infused within the sector.
So it seems like a very deliberate plan, even though as a space agency, you're thinking about how do you bring this into industry, how do you bring it into services? Are you targeting certain markets in the services sector? Is that how you view it?
Yes, we are. We're targeting the region as a first starting point. We are also collaborating with very close partners within the region itself to be able to catapult that. It's purposeful because we have 2 folds that we're looking at this. Research and development is a key pillar of economic development and diversification for the country. Technology is a lever within the country in terms of enhancing our competitiveness globally. And then international affairs is a third sort of pillar that allows us to ensure that trade continues across various platforms. We put all of these 3 different pillars of national economic development together at the space sector. So purposeful in terms of its overarching development of the space sector itself, intentional in terms of developing partnerships globally and ensuring that those partnerships are sustained moving forward, and then opening up new markets and creating new demand. So we do fund a lot of demand creation. We actually go into the client's footstep and tell them, we will pay for the development of a platform, or we'll pay for the development of, for example, one program was with regards to supporting using space data, better farming practices. So as an agency, we would provide that contract, and we'll provide that results to the sector that's in charge of it to ensure that they have a full understanding of it. So there's quite a conscious decision in terms of where we put the funds in and how we create demand in the key sectors of importance. And again, how do you determine those? It's where we know we'll have a competitive edge, first off in the region and then globally.
That's one. It's very deliberate. It's interesting, and a roadmap, I think, for a lot of other space agencies. So can you give some advice to other space agencies? If I'm in an emerging space sector in another country, I'm trying to have high aspirations, what kind of advice would you pass along to some of the other emerging space countries here?
So first is understanding what you want out of the space sector. And then the second is never going down the path of a copy and paste model. No space agency that exists around the world, or space entity, or space sector, or space organizations that exist around the world will fit in another country, considering the opportunities and objectives moving forward. So first is understanding the purpose. The second, and this is what we do quite intentionally in the UAE, also within my ministerial portfolio in advanced technology at our Ministry of Industry and Advanced Technologies, ensuring that we have a key understanding of what levers we want to unlock. So once you understand what your intention is from that sector, what levers you will unlock will then define what institutions exist within the remit of the sector, or the space sector in this case, the role of the government entity that will be supporting the sector as a whole, and then the stance internationally in terms of your international cooperation and development will also be dictated by that. And I think the last one, which is sort of an underlying factor, we're highly adaptable, just by virtue of being a new nation, we have to be. So there's new opportunities that come up every day. Yes, we do have long-term strategies for 10, 15 years down the line, but within them, there's a lot of nuances that allows us to iteratively redirect and iteratively find new opportunities, which is sort of being able to operate in white space and being able to adapt your programs to a white space that starts becoming known as you're moving forward. And it's sort of these different elements and ingredients that we infuse within our work and within the support that we provide for the space sector.
Fantastic. You know, I had the opportunity, obviously, to be in Dubai, where I was elected president, and have gone to other past air shows in Dubai. And I've always taken the opportunity to visit the space agency's booth. And I've always been amazed at the number of women engineers passionate about what they're doing that are engaged. I think almost envious from an American perspective, where we're struggling to actually build the pipeline to get women engineers involved in the space sector. Any hints or magic you can tell us as to how the UAE is able to attract so many talented young women engineers to be involved in space?
So for the space sector, role models worked quite well. So we do have a lot of engineers and scientists and researchers who are working within the sector. We fortunately don't have an issue of attracting girls into STEM, but we continue enhancing it across the different portfolios to ensure that is pushed forward. The second is due to the nature of our organizations, again, being new, that inherent bias that sometimes exists in organizations that have existed for decades doesn't exist in the creation and setup of those. So there's a lot of conscious and intentional understanding that lies within organizations, and we just come from a nation that ensures by law equal opportunity and equal pay for women. And that then supports in creating the right opportunities and the right venues moving forward in terms of its development. And we still see that. So I'm in charge of our public school system, and throughout the first few weeks of school with Sultan Niadi, our astronaut, coming in, you see a lot of engagement from children from various ages, and it's the imagery that we show to them in terms of their understanding of what lies behind getting to space, who are the people, individual that make it happen. Pictures, visuals help quite a lot in removing a lot of unintentional biases at a very young age for children.
I can imagine that you're a motivating factor when young women and girls look to you, what you've achieved already in your career. Let's talk about human spaceflight. Yes, thank you. I've got a couple of questions about human spaceflight and what the UAE's goals, both for low Earth orbit with astronauts and maybe to the moon and maybe Mars someday. Anything you can tell us about the ambitions there?
So I look at it from a research and development perspective at this point, in terms of ensuring what scientific benefits and outcomes we're getting out of it. How does it fit into the overarching development of our sector, and how do we ensure that we push that forward? So we're looking at various platforms to ensure an enhancement of research and development in microgravity, and that's your demand creation. And then from there, you're able to enhance the development of the program. The human space program then becomes a factor of a tool in terms of delivering on it, and it's very purposeful, like I think I've mentioned a few times during our few minutes here. But it creates the necessary impact and long-term implications of a very well-sustained and robust space sector.
I mean, you guys seem to really have a plan. I'm super impressed. Well, thank you for joining us.
So
really appreciate you.
Thank you very much, Your Excellency, for being with us. And we, without further ado, will switch again to the other side. The word is with Michal Hashimimari. Please.
Thank you. Thank you so much. First, I wanted to congratulate you on your new appointment with ASI, or ASI, as you guys call it. And we wanted to learn more about what you plan to do with ASI.
Thank you very much. First of all, good afternoon to everybody. And thanks for this invitation. I have accepted it with a great pleasure. Let me also congratulate with the organizer of this Congress with the amazing opening of this morning. Having said that, coming to your question, let me tell some general concept about space and then talking a little bit in details, more in details about the Italian Space Agency. What I see, even though I'm a newcomer in this scenario, is that the landscape of space is rapidly evolving and changing, and it is characterized by the entry of new countries, new players, including private entities, into the international space community. And all these interests have expanded the horizons of space activities, encompassing new sectors such as artificial intelligence, such as digital technology, such as quantum computing or quantum communication, additive manufacturing for space, in-orbit economy, and new human resources, policies, and strategies. Having said that, and coming to the Italian agency priorities, as you said, let me first of all say that I have assumed my duty, my position, just 4 months ago. So we have a national space plan and a 3-year activity plan whose activity will continue following the guidelines set by the new governments with a budget for this year which is around 2.3 billion euros. We have activities running which are related to the Italian National Recovery and Resilience Plan, which are related to SATCOM, up and downstream Earth observation, for example, satellite constellations, the development of ASI Matera Center, Space Factory, access to space, and in-orbit economy. And at the last ESA Ministerial Council, which was held in November 2022 in Paris, Italy significantly increased its contribution to around 3 billion euros, investing in all main sectors such as Earth observation, space exploration, launchers, telecommunication, navigation, etc. Then we do have also the European programs. And for the agency, the priorities, they are linked to Copernicus, to Galileo, GovSatcom, SSA, and Horizon Europe programs. We do have in mind the idea to strengthen the Italy position in technological sectors, which can guarantee or from which we can expect high returns and development prospects. And then other priorities at EU level are also linked to the new IRIS Square program and to the space traffic management topic. Then we do have the international chapter. And at international global level, we have many cooperation agreements and projects with several partners, and we want to continue to strengthen this line. Partners are many. First of all, NASA, with which we do have at least 40 cooperation agreements and new comings with our friend of Japan, JAXA, India, Israel, Canada, GSA, Israel, Australia, United Emirates, and last but not least, let me mention also the Kenyan Space Agency, with which we have an historical and a strategic collaboration for both the countries. Then in the sector of the space exploration, we have a growing interest in sending humans to explore the moon, Mars, and beyond. And Italy, which is an early signatory of the Artemis Accords, is also actively engaged in developing an habitation module among the first to grace the lunar surface. Within the Earth observation area, our commitment is to progress and innovation is unwavering. Currently, we are advancing the second generation of our radar satellite, which is constellation, which is named, as you know, Cosmos Skymet, a great success. And together with the development of the Iride constellation, which will be equipped with multiple sensors and which is in swing, along with the hyperspectral Prisma satellite. And in parallel, we also provide steadfast support to the research community, which is very wide in Italy, dedicated to this class of sensors. I want to mention it, but another significant pillar, well-consolidated investment in Europe on our side, also on the French side, is the development and support of launchers. I refer to Ariane and to Vega, even though we have some small problem, let's say hopefully, in this period, but we cannot have exploration, or we cannot have activities in space if we do not have access to space. So they are strategic issues. Then, with the increasing number of satellites, spacecrafts, and debris in Earth's orbit, also the space traffic management is becoming a critical concern, and our agency, through its competence and facilities, can help in tracking and manage space objects, predict potential collisions, and optimize, for example, satellite orbits to reduce congestion and minimize space debris. I want to mention also another couple of things which are strategic for the Italian Space Agency. We are in the developed phase, actually, of FlyEye, which is a network of 4 telescopes with large observable area located in different places in the world. One is in Italy, in Sicily. They are connected to enhance sky observation. However, even though we are just talking about technical matter, the future of space, up to my side, extends beyond the technologies, missions, markets, and space economy, because we firmly believe that international cooperation will be paramount in shaping our collective journey into space, and so we will continue to follow also this line with all our expertise.
Thank you. So although it's been only 4 months, it seems like you're going to be extremely busy with all these objectives and collaborations that you have. So one element, as you know, we have a growing space economy and then an introduction of the cislunar economy. So it's going to get pretty busy globally. How do you think we can correlate space and peace? And how do you think the Italian Space Agency can be a promoter of peace in space?
Thank you for this question, which is a very important question. And as we all know, historically, space exploration has often been framed as a peaceful endeavor. And the Outer Space Treaty, which is governing the activities of states in the exploration of outer space, it was signed in 1967 and is a primary example of this statement. It established principles such as the prohibition of placing nuclear weapons in space, the use of the moon and other bodies, celestial bodies, obviously, exclusively for peaceful purposes. And the treaty reflects the international community's desire to maintain the focus on scientific, cooperative, and peaceful goals in space exploration. And this is also our aim. But however, it is important to be honest, to recognize that the space also can present challenges for peace. For instance, the deploying anti-satellite weapons or other space-based offensive capabilities raises the risk of destabilizing actions. Thus, while the space exploration itself is not inherently giving automatic output of peace, all the nations engaged in space activities must actively contribute to peace and stability through international cooperation and going on with the already existing efforts. This is the reason, because to your question of before, I mentioned the international collaboration as a very important issue, because that one is the tools with which we can give our contribution for peace in the world.
Thank you.
Okay.
Thank you very much, Professor Valente. And we switch again over on my side. Clay, please.
Thank you, Christian. So I have with me Dr. Hiroshi Yamakawa from JAXA. He's the president. He's an engineer, a professor. You've designed spacecraft, I think worked on interplanetary missions like to Mercury, Bepi Colombo.
Yeah.
Rocket systems, really incredible background. Was in the cabinet office as well with the Japanese government, and has been since 2018 the head of JAXA. Thank you for joining us today.
Well, thank you very much.
Yeah. So can you tell us about your plans, your prospects? Where is JAXA heading today?
Well, first of all, I would like to say it's always a great pleasure to be part of IAC, and it's always a great honor to be part of this great session. Thank you very much for that. Well, first of all, JAXA, as a national space agency, is a research and development agency fundamentally, but at the same time defined as the core implementing agency to support the overall activities of the Japanese government. So we would like to concentrate on those two aspects. And talking about the launching satellites, I'm very pleased to mention that about 3 weeks ago, our rocket, named H2A number 47, successfully launched 2 scientific satellites from Tanegashima Space Center in Japan. One satellite is called XRISM, which is an X-ray astronomy satellite, which is a really great mission, a joint mission with NASA and ESA, and also the Netherlands. And the other satellite we launched using that rocket is called SLIM, which is means the very S stands for smart, so it's a smart lunar lander. And right now, both satellites are in very good condition, and we are operating those 2 satellites currently. And I will talk about those missions hopefully in the next question. But and the other thing I would like to say is that we are having a wonderful international collaboration, for example, with India, and I would like to talk about LUPEX, which is a joint mission with India, ISRO, and we will together launch a lander and rover, and ISRO will be responsible for the lander, and JAXA will be responsible for the rover. But anyway, that will be a great, fantastic mission for both of us and for the world, hopefully. And the other mission I would like to talk later is the MMX, which is a Martian Moon exploring mission, which is going to get samples of the Martian moon Phobos and return the sample back to the Earth.
Very good. Well, I know that you launched the HOPE mission as well, right, on a Japanese rocket as well. We were talking about it earlier today. So lunar planetary exploration, what's the path? Everyone's talking about the moon here. Tell us about JAXA's plans for lunar exploration.
Yes, I would like to talk a little bit in detail about the missions which I've just mentioned. One is about the SLIM mission. As I said, we launched that lunar lander spacecraft 3 weeks ago, and currently we are in an initial operation phase, and we already inserted that SLIM spacecraft into the lunar transfer orbit right now, and it's really in healthy condition right now. So we're looking forward to insert that spacecraft into lunar orbit and finally realizing lunar landing, maybe hopefully in several months from now on. And about the MMX mission, and MMX is a challenging mission also, but it's really based on our experiences such as the Hayabusa 1 and Hayabusa 2 mission, which realized sample return from an asteroid. And so based on those experiences, we would like to further move on to the next challenging mission, that is MMX. And MMX is also an international collaborative mission together with CNES, French Space Agency, DLR, German Space Agency, and also, and again, NASA and ESA. So I think those two missions will realize and pave the way forward for both of us. Both means our counterpart, international partners.
Very good. Well, Pam Melroy was talking about the excitement building around the Artemis mission and about international participation and the incredible number of agencies and countries that have signed the Artemis Accords. Human spaceflight for Japan, what's the future? How does it look for lunar
well,
Artemis?
Thank you very much for the question. We've been engaging in human spaceflight under the framework of International Space Station so far. And, but we would like to move on participating in the Artemis program as well. And first of all, I would like to say that the Japanese government signed the Artemis Accord as one of the first 8 signatories. And so based on that accord, and we would like to move on. And concerning the Artemis program, we would like to contribute to, for example, the Gateway, the Lunar Orbiting Space Station Gateway from especially the ECLIS point of view. ECLIS stands for, as you know, Environmental Control and Life Support System. And so that's one of our contribution to the Artemis program. And the other part is that we would like to contribute to the Artemis program by providing a cargo transportation function to the Gateway. That's number 2. And third, I would like to say that we also would like to contribute to the Artemis program on the lunar surface. And right now, JAXA, together with the Japanese automaker Toyota, is working together very hard in order to realize a crewed pressurized rover. And it's really a great, it's really, I would say, gigantic rover because we will have 2 or more astronauts on board the rover to do so many things, of course, including driving the rover.
Yes, of course. Moon, yeah.
And the reason why we are focusing on pressurized rover is because the Artemis program itself is a sustainable exploration on the surface of in the vicinity and on the surface of the moon. And if the astronauts have to wear spacesuits driving rovers, then it will not be sustainable. It will last only several hours. So that's why we stick to pressurized rover to realize sustainable exploration on the surface of the moon.
Excellent. So we know that space is growing. We know there's a lot of new actors in space. I think SpaceX alone has over 4,000 satellites now, close to 5,000 satellites in orbit. And orbital debris is becoming a very big issue. And one of my tenets is sustainability in space is something that we're trying to get the focus on here at the IAF and at our congresses and events. Can you tell us your view on space debris, orbital debris? What is JAXA doing? Do you have some focus in Japan on this?
Well, yes, thank you. Well, space debris is a problem for everybody, of course. And JAXA, or I would say Japan, has been engaging in SSA activity, space situational awareness activity for more than 20 years, utilizing our own assets such as optical telescope and radar system specific for SSA system. And we have to do that because we have to protect our own satellites, of course, but at the same time, avoiding collision with each other is to avoid collision with, space debris in the future. Because if there are, for example, 10 large-scale collision between space debris or satellites, then the low Earth orbit will be filled with a a number of space debris. So then in that case, low Earth orbit will be a place for nobody. So that's one thing we are doing right now. And the other thing I would like to say is that for the next step, we would like to actively refine the low Earth orbit environment. I'm talking about the active space debris removal. And we are right now engaging with our Japanese private sector to realize that. And the phase one, we have two phases. The phase one is dedicated to get the knowledge or information of the already existing space debris, the target space debris we would like to remove in the near future. And because we don't know the actual, I would say, attitude or spin rate or something like that. So the first phase, we get the information of that kind of things. The second phase, we will actually remove that space debris down to the Earth atmosphere.
Okay. So we talked about that. Obviously, that's a big challenge, more orbital debris. We talked about global challenges and opportunities. Give space a chance here is the theme of the Congress. What is JAXA doing to address other global challenges? What do you see? Climate change, other things that are facing the world?
Yes. I think then I will talk about the EO satellites, Earth observation satellites. We are currently operating 6 Earth observation satellites, and mainly for disaster response, disaster management, and the other objective is to tackle climate change as one of the biggest, global issues recently. And for example, we are operating 2 satellites dedicated to observation of greenhouse gases, such as carbon dioxide and methane. And the name of the satellites is GOSAT-1 and GOSAT-2. And we launched that satellite about 14 years ago, and that was the world's first satellite dedicated to observing carbon dioxide. And so we already accumulated 14-year data of GHG gas.
Nice to meet
And
you.
so we would like to contribute to international fora such as United Nations to address climate change using those data.
Very good. I have a question about Sarah Alamiri talked about how they work and foster their industry with very kind of deliberate plans to work with startups and other in industry around the services sector. I know a few of the Japanese new space companies, Gitai, Astroscale, others. Can you talk about how JAXA works a bit with fostering new companies in Japan and building technology?
Yes. For example, we have an initiative called JSPUG, and we would like to, respect the new startups' business model. And so we would like to contribute to or providing comments to those business models if it's feasible or not from technical point of view. But from the other point of view, we would like to work with those private sectors to also to utilize technology or data for JAXA missions, of course. So we are working together, working very hard to realize both business and also JAXA missions together.
Perfect. Dr. Yamakawa, thank you very much.
Thank you very much.
Arigato.
Thanks a lot, Dr. Yamakawa. And we switch back again on the other side to Misha.
Thank you. Thank you so much for being here. You're a seasoned politician, and this is not a new area for you. You've been Deputy Defense Minister, you've been Deputy Prime Minister as well, and Industry as well, Ministry of Industry. So what we would like to know a little bit more is that we know that the Russian Federation announced extension of its support of the International Space Station until 2028. Could you tell us a little bit more about the new Russian orbital space station that is being designed today? What are its roles, and will any of it be related to climate monitoring?
Спасибо. Но я сначала хотел бы поблагодарить организаторов и в первую очередь принимающую сторону, Азербайджанское космическое агентство, за прекрасно организованный форум и за возможность принять участие в нем.
Thank you so much for your question. But first of all, I'd like to thank the host country and the host side, the Azerbaijani Space Agency, and the organizers of this great event.
Что касается наших планов по пилотируемой космонавтике, мы действительно продлили наше участие в международном проекте МКС до 2028 года. Дальнейшее участие будет определяться техническим состоянием этой станции.
As for the extension of the support of the ISS service until 2028, our further decisions will be outlined by the technical state of the ISS in the future.
К сожалению, этот замечательный проект когда-нибудь закончится, станция прекратит свое существование. Я подтверждаю, что мы с нашими коллегами примем все необходимые усилия для корректного свода ее с орбиты.
Unfortunately, this great station will come to an end one day, but I can assure you that together with our foreign partners and colleagues, we'll do our best in order to ensure the correct deorbit of this station.
Мы не собираемся прекращать свою пилотируемую программу, и с этой целью мы разрабатываем проект российской орбитальной станции, который должен быть реализован поэтапно с 27 по 32 год.
In any case, speaking about the manned, the crewed astronautics and space flights, we don't want to reduce at all our contribution to this sphere. That's why we are designing and developing our new national Russian orbital station, Rosa, which is expected to be set up in 4 stages, starting from 2027 up to 2033.
Задача этого проекта не просто продление пилотируемой программы, но и освоение новых технологий в околоземном пространстве, разработка новых материалов и лекарств.
In any case, the main objective and goal of this program is not to maintain our activity in this sphere, but also the development, design, and test of new components and new materials.
В 2027 году мы собираемся запустить научно-энергетический модуль, затем последовательно узловой, шлюзовой, базовый и целевые модули и завершить строительство станции в 1932 году.
For this reason, we're expecting to design, to manufacture, and to launch several modules by 2027, a node, gateway, telecommunication, and our also basic modules for this station.
Как вы знаете, наша страна накопила, пожалуй, самый богатый опыт и компетенции в области создания подобного рода станций. Но у этого проекта есть 2 особенности. Первая – это новая орбита, полярная орбита, где совершенно другие условия, в отличие от МКС.
As far as you know, our country has accumulated a really huge, impressive experience in this sphere. But speaking about this new Russian orbital station, ROS, in comparison with the previous generation of space station, it has 2 specific features. First of all, it will have a new orbit, which has its own specific conditions.
Конфигурация станции будет предусматривать смену модулей, поэтому время жизни этой будущей станции будет значительно выше, чем МКС.
And also the configurational scheme of this new Russian station will provide for the possibility to change modules. That's why it will be possible to extend the life service of this new station as long as possible.
Станция будет иметь высокую энергетику, то есть энерговооруженность, что позволит организовывать различного рода эксперименты, освоение новых технологий, разработку новых материалов, лекарств, и будет работать как постоянно действующая лаборатория по отработке космических технологий.
And this new station will have a very strong and a stable power supply, which will make possible to make different tests and experiments, testing new materials, new technologies, new medicines. It will be like a permanently functional laboratory.
Мы открыты в этом проекте к международному сотрудничеству от посещения и подготовки космонавтов и работы на этой станции вплоть до разработки и производства отдельных модулей, которые, кстати, могут и не пристыковываться, летать рядом, и для проведения международных экспериментов.
And we are totally open for the international cooperation, speaking about the new orbital station. That's why we are ready to discuss the possibility of other astronauts to visit these stations, as well as we are ready to support in training astronauts and also in design of specific separate modules that not mandatory to be connected directly to the station, but that can operate close to the station.
Thank you so much. That was very insightful. As you know, space technologies have entered our lives. We're using it more and more, and we're depending on it increasingly. And it's becoming part of the market, goods, and services on the daily. The demand for space services also stimulates the growth of potential development of space technologies. Countries are rapidly increasing the number of space constellations. So what we would like to know is, could you tell us more about the role of multi-satellite constellations in the Russian space program and briefly outline the direction of their development?
Вы абсолютно верно подметили создание многоспутниковых группировок с целью удовлетворения широкого спроса на космические услуги. Это является устойчивой мировой тенденцией.
You totally correctly mentioned that today the development of multi-satellite constellations is the actual trend in order to satisfy the growing needs of space services.
Россия также работает по созданию этих группировок с целью удовлетворения широкого спектра космических услуг. Мы имеем программу «Сфера», что собой представляет совокупность многоспутниковых группировок, 5 телекоммуникационного направления и 5 систем дистанционного зондирования Земли.
That's why in our national Russian space development program we have plans for developing and deploying multi-satellite constellations. That's why we're developing our project, which is named Sphera, in order to satisfy a really very large of demands and needs in space services. And this project will consist of a few multi-satellite constellations, more exactly 5 telecommunication constellations and 5 remote sensing constellations will be included to this project.
Мы приступили к созданию группировки обзорного типа сверхмалых спутников под названием «Грифон». Это 136 аппаратов на орбите, которые с высокой интенсивностью будут давать информацию о любой территории нашей страны и всей территории мира.
There is another project which is named Griffon, which provides for the deployment of the ultra-small satellites consisting of 136 satellites, which will provide the update of the imagery of the Earth surface with a very high periodicity, not only of the Russian territory, but of the whole planet.
Безусловно, система предусматривает широко разветвленную сеть наземную сеть приема и обработки информации. И с помощью этой системы можно получать огромного рода сервисов на базе стримингового потока информации от этой группировки.
For sure, this system, Griffon, will require a very large ground station for receiving and processing information received from satellites in order to provide a really very large range of different streaming data flow services.
Thank you so much. The other area which we talked about, multi-satellites, there's a high cadence of access to space over the past few years. More and more constellations are being launched. So there are some risks associated with these human-made pollution near Earth. Can we talk a little bit about what Russia is trying to do to provide solutions with regards to the space debris that's out there that is continually being added in space?
Проблема действительно актуальна, и она затрагивает практически все страны, которые занимаются исследованием космического пространства. Вы знаете, что у нас была нештатная ситуация в декабре с нашим кораблем «Союз-23», и это уже не редкость. За 2022 год около 600 случаев приближение различного рода мусора к 4-километровой зоне работы МКС и около 16 тысяч случаев приближения на 1,5-километровое расстояние от спутниковых группировок, так что эта проблема актуальная.
You're absolutely right, as this problem became really vital for almost all the countries which deal with the space exploration. And I'd like to add that one of the confirmation of this fact is the incident we had last December with the launch of Soyuz 23. Unfortunately, today it's not a rare phenomenon. In total, for 2022, we have registered more than 600 cases of violations of 4-kilometer safety zone around the ISS, as well as more than 16,000 cases of dangerous approaches in 1.5 safety kilometers to multi-satellite constellations have been registered.
Россия сегодня имеет систему мониторинга космического пространства АСПО-САКПО, но планирует развивать эту систему, и мы предлагаем, опять же, в рамках международного сотрудничества создание системы, мы ее назвали «Млечный путь», которая призвана как раз осуществлять детальный мониторинг космического пространства с помощью использования оптикоэлектронных, радиотехнических и радиолокационных средств.
Today, the Russian Federation has also its own system of operational monitoring of near-Earth space, but at the same time, we're aimed to develop a new system which is called the Milky Way with our foreign partners and colleagues in order to provide and ensure the detailed observation and monitoring of near-Earth space, including the use of different types of spacecraft in the optoelectronic, radar, and other ranges.
Система позволяет около 15 миллионов измерений осуществлять в сутки, обеспечивает высокую достоверность наличия искусственных или естественных объектов в космосе с целью предотвращения столкновений.
This system guarantees the huge amount of measurements to be done per day, which approaches 15 million measurements per day, and it will provide for a possibility to identify the presence of natural or artificial objects in the orbit.
Подобные системы носят глобальный характер и, конечно, на наш взгляд, должны создаваться в тесном взаимодействии и при широком международном сотрудничестве. По нашему мнению, страны, которые будут предоставлять свою территорию для создания необходимой инфраструктуры, взамен должны получать всю необходимую информацию для безопасности своих национальных космических группировок.
But in any case, in our opinion, this kind of system has a global, universal character. That's why we are open and we are waiting for a very large international cooperation, as all the countries dealing in this sphere and which are aiming to develop their ground infrastructure, for sure they should get really very accurate, operational, exact information.
Thank you so much. For sure, collaboration will be critical to address this issue. Thank you.
Thank you, Mr. Borisov. And we switch here to our last round. To my side, Kay, the floor is yours.
Thank you very much. I'm pleased to welcome my friend, Dr. Samarnath, who's chairman of the Indian Space Research Organization. Illustrious career as a rocket scientist, beginning his work on PSLV, and then is seen as the father of the GSLV Mark III system. And I would say humbly that he's now a rock star in India, having successfully on August 23rd, yes, successfully become the 4th country in the world and the very first to land on the South Pole of the lunar surface with Chandrayaan-3, with the Vikram lander and Pragyan rover. So tell us about this. This is a huge achievement. It must be very exciting in India. So,
thank you, Clay, for the introduction. I would like to specifically thank IAF and Asa Cosmos for this fantastic organization of IAC this year. The inaugural function was so wonderful, and we look forward to a great IAC this year. In India, the landing of Chandrayaan-3 created such an interest and a public opinion, especially amongst youngsters and young people. I think you know that it has been the most watched event in the YouTube in the recent times. So it created such an interest and inspiration for the entire country, for young people to come into science, engineering, technology. It's a very important topic for us. And more than that, I believe in India, we have been looking at space as an agency for creating applications for governance and ease of life, not really into exploration or technological marvels that need to be done as a spacefaring nation. But then, after accomplishing certain things in the application sector and creating some impact, we have been trying to do a little bit of exploration, science, etc. with our budget. But the Chandrayaan-3 created such an impact that now everybody is talking about why not do more in the domain of exploration. So we have programs in the coming for looking at Moon, Mars. Of course, we did a Mars mission, and also planets like Venus. Continuation of exploration of Moon in the future. Maybe more complex things are in the offing. So these are the two immediate outcome out of the Chandrayaan-3, the huge support that we are getting in terms of working in space, and also the expectation for the nation like India, who want to use technology as a tool for transforming our nation.
Well, I know Prime Minister Modi said that this was not just India's success, but really, what can you say about international cooperation going forward? Where does India see itself in cooperating with other nations on space exploration?
For a country who advocates Vasudhaiva Kudumbakam, we call it, the whole world is one family. For a Prime Minister who advocates that, what else he can speak about this accomplishment? When we landed successfully, safely on the Moon, and the scientific outcome that's going to come out of it, it belongs to the humanity. It was so in the case of our past mission, Chandrayaan-1, which hosted payloads from US, it hosted payload from the Europe, and India as well, and it was the one which found out the traces of the water on the Moon for the very first time. And so is the Chandrayaan-2. And we would like to make sure for those missions which are going to happen in the future, we would like to have a greater participation. As already been told by JAXA, that we are working together on a future Moon mission. We are working with NASA on looking at Earth and tectonics through the synthetic aperture radar satellites, and future scientific missions. Definitely we would like to host payloads and instruments and working with the scientists from across the globe.
I had the opportunity to visit you in Bengaluru earlier this year, and it was leading up to the G20 that was taking place in India, and I know this was a huge achievement as well, very successful. What were the outcomes of that G20 and in particular the space economy space leaders meeting?
Yeah, in G20, space is still not a formal agenda. It's only discussed as a topic, especially in the domain of economy and how the benefit of space is being useful. So we discussed in the sidelines of G20. So that's why it's called Space Economy Leaders Meet. But the important takeaway in this is that we wanted to advocate three key areas in space. The first being the business and economy. So we advocated a new term called Space Era, ERA. The E stands for economy. Unless business comes in and there are factors that drives space, it won't grow beyond a point. And the second element is the responsibility. Of course, looking at responsibility, we see for space agencies who are already reached certain level, and we want to have new actors coming into space. Unless the application of space sector grows in domains other than those few players, it really doesn't grow in terms of size of economy. So we want the restrictions in space sector to go. And we want the highest of the technology being accessible to players from many other nations. So this is the second important topic. And responsibility is equally important. For us, for ERA, for A, we say the alliance is also important. See, we see that the new actors, that the space agencies which have reached certain threshold of their accomplishment And for the aspiring nations who want to come into space, the only way to grow, as we heard from UAE, is to have connection between the new actors and the old established actors and create new alliances across the globe. So we try to say under the G20 framework, we need to work on each of them. And there was a huge amount of support for that idea.
Wonderful. We have this theme, global challenges and opportunities give space a chance here. How do you see the global challenges? How is ISRO's position to help us solve some of these global challenges?
So there are many. In terms of the global challenges, we see the sustainability, the environment, the climate change remains one of the top priority for all of us. And of course, we have been working with many agencies in this area in the past. For example, with the French agency, we have launched satellites to look at the tropical weather and the climate. And we have been providing data in the climate and weather parameters. As you mentioned about the essential climate variables, large number of them comes from the space. And we have been the contributor of some of these measurements globally for the global community who makes models and predictions for it. And we would like to work to put more instruments in our future satellites for contributing to the essential climate variable monitoring across our satellites. We have an ocean sat which looks at oceans very specifically, and this is one of the very important payload that is providing global data. The scatometers, which gives the wind vectors, is one of the globally very demanding data. And we recently announced, our Honorable Prime Minister Modi ji has announced one satellite called G20 satellite. He wanted to make sure, though it is under the umbrella of G20, he wants to make sure this is a global satellite specifically configured to address the global climate, environment, and other hazards. And we are going to build and launch it from India, but we seek payloads and scientific instruments from across the globe, scientific instruments which we can host on the satellite and can be a data provider for the whole of these countries. So this is one goal that we are setting for next 2 years. We would like to build the satellite and launch.
I love this idea, global satellite. No pressure for the launch.
Thank you.
Loved it. You have a solar exploration mission as well. Can you talk about how is that uniting, exciting the scientific community in India?
See, the scientific community in India is not just within our organization of space, the ISRO. No, it's actually widespread. There are many university systems. There are government-funded laboratories. We have IITs and scientific institutions spread across. So for the solar mission, we made sure that the payloads and instruments that are going to be hosted on board are not from ISRO. We worked with our scientific laboratories, and the heliophysicists across the country came together. We have an observatory, the terrestrial observatory. So they started building these instruments. Actually, the satellite took almost 10 plus years to conceive and build, primarily because we wanted to make sure the instruments are built not by ISRO, by the collaborators. So we have on board payloads like the solar coronagraph, which is built by Indian Institute of Astrophysics, which is it's not an ISRO organization. We have another instrument, which is the ultraviolet spectroscope built by Inter-University Center for Astronomy and Astrophysics and various other instruments. So it actually created the synergy between scientists in India and across various scientific establishments, educational institutions, academy, and other laboratories to come together to study sun. And such an exciting payloads suite that we have. We have 7 instruments on board on Aditya, which actually looks at the coronal mass ejection up to its secondary effects, like the particles, the magnetic effects, everything can be seen concurrently through a single mission. And that's the uniqueness of the Aditya L1.
I just have one more question, if I may, Christian.
Yeah.
So I got a couple of questions in the Slido here about new small launchers in India.
Yeah.
As a father of Indian launch, how do you view these guys? What's the status of some of these new startup rocket launch companies?
No, there are many enthused to work in the space sector. Now we have almost 200 startups in space. At least 3-4 of them are in the rocket building, and some of them are successful in launching suborbital sounding rockets now, and the second one is getting ready for launch. And I'm really happy to see the enthusiasm in building rockets, though it's a very tough thing to come through it and then become successful. We help them from our agency in terms of the facilitation, in terms of the technological support to make sure they succeed. But then to become commercially successful is really tough, but I wish them all the very best at this time. We also did the same exercise of building a small rocket based on our experience to look at how we can do it very cost-effective manner and then transfer that technology to the private sector in India to build and launch it on a commercial basis. And that's happening very well. And I see an emergence of small satellites and small rockets going together to create a to create real impact in this sector.
Thank you very much, and congratulations again on the lunar landing.
Thank you so much.
Thank you very much, Mr. Sommernath, and I would like to remind you that you will hear more about this exciting mission, Chandrayaan-3, on Friday morning at our late-breaking news session. And now I would like to thank our two moderators, Clay, Michal, thanks a lot, and of course a big thanks to all our global space leaders for your intervention. Please give them a round of applause.